Hi there, welcome to the addition formula lesson as part of the trig topic at Higher Maths. I'm not going to go through the proofs for you today because I don't think a lot of people find that valuable. That will be done or should be done in class with you. I'm just going to show you what the addition formula expansions are and how to use them. So I'm going to show you first just sine of a plus b. I'm going to show you a couple of examples of that, and then I'm going to use all four expansions of the addition formula. And specifically within that, there's a couple of examples using the trig ratios of SOHCAHTOA to simplify them. Okay, now this is your first compound angular addition formula equation or expansion. So sine A plus B, it does not just become sine A plus sine B. There is this more complicated expansion that is on your formula sheet, so you don't have to remember it. Okay, just take a wee second and copy that down for me, please. Now, if you expand sine x plus 60, just like here, and here you've got a first, and there you've got x. Everywhere we see an a, then we're going to see an x. The second thing there is plus b. This time it's plus 60. So everywhere we see a b, we're going to replace it with 60. So it's going to be sine a cos b, or in this case, sine x cos 60 plus cos a, which is going to be cos x sine 60. Sorry, my pen's going to pull up. Okay, but this time we know what cos 60 is. Cos 60 is a half, so that's really going to be a half sine x. And I'm going to add on, well, sine 60, that's really root 3 over 2, so it's going to be root 3 over 2 cos x. So that is a simplified expansion, or an expansion of sine of x plus 60, half sine x plus root 3 over 2 cos x. Sine 75, we're looking for the exact value, but we don't know the exact value of sine 75, so we can't give it, okay? But what we can do is we can say, well, actually, that's sine 75, excuse me, sorry, that's sine 75. Well, we can write that 75 degrees as 45 add 30, which means we can use our expansion to answer that. So sine 45 plus 30, well, that's going to be sine 45 cos 30 add cos 45 sine 30. And we know all those exact values. Sine 45 is 1 over root 2, cos 30 is root 3 over 2, plus cos 45, which is also 1 over root 2, and sine 30, which is a half. And then if we just simplify that, that's going to be root 3 over 2 root 2, add 1 over 2 root 2, which is just going to be root 3 plus 1 over 2 root 2. Okay, and lastly, and this is where we're talking about the trig ratios coming in. Find the exact value of sine p plus q. Well, if we're looking for sine p plus q, we know from our formula expansion that really means sine of p cos q plus cos p sine q. Oh my pen is putting up all sorts today. Okay, now because we have these triangles here, we can calculate what sine p and cos q are. So in here, because we've got this triangle, that's 3, 5, well automatically we know that's 4 from Pythagoras. Same there, that's 5, 12, use Pythagoras, that's 13. So sine p is opposite over hypotenuse, 3 over 5, multiplied by cos q, which is adjacent over hypotenuse, so 12 over 13. Add the cos b, adjacent over hypotenuse, 4/5. Sine q, opposite over hypotenuse, 5/13. Okay, and then just do the sum, that's 36 over 65, add 20 over 65, so altogether that'll be 56 over 65. Okay, so sine p plus q can be simplified to that. Okay, now that's us only dealing with one one expansion. Now the other expansions are very similar and you're going to deal with them in exactly the same way, so I won't worry too much. There's all four expansions wrapped together, and that's how it will be given in the formula sheet. Notice your plus minus means that if you've got a plus b, then that one here matches up. So a plus b will be plus, a minus b will be minus, but in the cos one, it's the other way around. So if you have plus in there, it has to be negative here, and if you have negative here, it has to be plus. Okay, now we have those expansions, and we've got another couple of examples here. So if we're looking for sine of a minus b, you can see for our expansions that it's sine a cos b, subtract cos a sine b. Okay, now the only information we have here is here. Now if tan a is 9 over 12, we know that tan is equal to opposite over adjacent. So we can draw a triangle there with tan, with a, where the opposite is 9 and the adjacent is 12. And using Pythagoras again, that gives me 15 for the hypotenuse. And then we can get cos and sine of a. So the sine of a is going to be opposite over hypotenuse, so 9 over 15. Cos a is going to be adjacent over hypotenuse, so 12 over 15. And then similarly for b, we can do a right angled triangle again with b. Now we know that sine is opposite over hypotenuse, so the opposite to b will be 4. That'll be root 32. And then when we do Pythagoras again, that'll be 4. There we go. Okay, and then we can do exactly the same again. Cos b is going to be 4 over root 32. And sine b is also going to be 4 over root 32. And then just multiply out, that's 36 over 15 root 32, subtract 48 over 15 root 32, which is equal to negative 12, 15 over root 32. Okay, and that's you. Well, actually, it simplifies a bit more in the subs, but I'm not going to bother doing that on the video. Okay, and lastly, a slightly trickier question. The gradients of OA and OB are 3/4 and 12/5. Find the exact value of cos AOB. Okay, so AOB is going to be that angle in there. So cos of AOB is equal, well actually that's going to be angle B. Okay, so angle from there to there, take away that angle there. So let's call that whole one angle B and this small one angle A. So really this is cos of all triangle subtract A. Just go try and get that up there a second, sorry. Cos of E subtract A. And we have our expansion. Cos B cos A plus sine B sine A. Okay, now this is a slightly trickier question, but we've cracked the first part of it. Now the second thing we'll look at is that gradient there. OA is 3/4, and we know that gradient is vertical over horizontal. So that means in there the vertical is 3 and the horizontal is 4, which means your hypotenuse is 5 of that right angle triangle, and we've got values for cos A, which will be 4 over 5, and sine A, which will be 3 over 5. And then in a similar way, for B, we know the gradient is 12 over 5. So the vertical will be 12, the horizontal will be 5, which means the hypotenuse is 13. So cos of B is 5/13ths, and sine of B is 12/13ths. And then simplifying that, that's going to be 20 over 65, and 36 over 65, which is our 56 over 65 again. Okay, now hopefully if you know your expansions, this is just the case of using expansions. The trick comes with your trig, either within using the triangles, if they don't give you the triangles, drawing the triangles, or something like this where they give you gradients as well. But the expansions are the key thing here. Okay, knowing how to use these expansions, not even knowing them because they're on your formula sheet, just knowing how to use them.